Hello friends, myself Kedar Acharya and I am going to present you my final year project. The title of our project is Investigation of Critical Parameters of Lubricating Oil Affecting the Performance of Hydrodynamic Journal Bearing. Our project is guided by our internal guide Professor Ajit Salunke of Don Bosco College of Engineering and external guide Mr. Nilesh Desai, who is the DGM of Zuari Agrochemicals Limited. The main aim of our project is to find the critical parameters of the lubricating oil, that is viscosity in Sandy Stokes and the acidity of the lubricating oil in pH. Now I am going to show you the process diagram of our process equipment. Here you can see the flow diagram of our process equipment. The oil is transferred from the oil sump and to the pump, the oil filter, heater and heat exchanger and back to the oil sump. Between the heat exchanger, we have placed two sensors. One is the temperature sensor and one is the pH sensor, which gives the output to the deck card. And the oil finally comes into the oil sump. This is our process equipment, and as you can see that this is the oil sump, which has the capacity of 70 liters. The oil pump which is installed is a centrifugal dive and which pumps the oil from the oil sump to the heater. The heater has the capacity of around 80 degrees Celsius, that is it can heat the oil up to 80 degrees Celsius. After the oil has been heated, the hot oil is passed to the heat exchanger. The heat exchanger has a effectiveness of reducing the temperature to 40 degrees Celsius temperature difference. Between the heater and the heat exchanger, we have installed two sensors. One is temperature sensor and second one is pH sensor. This is the pH sensor or the pH electrode which gives the output in terms of millivolts. This is the thermocouple which we have installed which also gives the output in terms of millivolts. The RPD sensor which we have installed gives the output in terms of milliamperes to the temperature controller which shuts off the heater once it attains the 80 degrees Celsius. Now I will come to the signal conditioning. The signal conditioning is basically the amplifying of the millivolts and the milliamps to the voltages 1 to 5 volts. And this is the signal conditioning. Circuit to which the outputs of different sensors have been connected. After it has been amplified, it has been gone to the national instruments deck card, the analog inputs 1 to 5 volts. The deck card converts the analog inputs to the digital outputs and it goes to the CPU, to our LabVIEW program. This is the deck assistant data which you can see, which takes the voltages, and it has been displayed here what the value of the amplified by the signal conditioning circuit. This is the LabVIEW program. This is the block diagram. What you can see is the programmer's view. This is the while loop which you have taken. The voltage has been converted into the corresponding temperature in degrees Celsius. This temperature has been input to the threshold array. Threshold array selects the corresponding temperature from the temperature array, and then the temperature goes to the fractional interpolation array, which selects the corresponding viscosity. The viscosity has been displayed in terms of centi-Stokes. Finally, the program attains that if the corresponding temperature goes above the certain value, an alarm will be rang. Same will be to the viscosity. Similar logic has been applied to find the pH value. The samples of oil were tested in our setup and the results were tabulated as follows. Table 1 shows that the lubricating oil, one of fresh sample and other used oil were tested in Zuari Agrochemicals Limited laboratory, and the same samples of the fresh oil and the used oil were tested in our process equipment which is kept in the mechatronics laboratory. You can see that the viscosity found in Zuari laboratory is 324 of the fresh oil and 352 of the used oil. we found the fresh oil viscosity to be 307 and used oil to be 331, which is quite compatible. From this we can conclude that our setup is suitable for oil analysis purpose. Thank you.